And thanks for everybody who could follow until now to listen to this last talk. I will talk on the Arbon Demonstrator and how smart meter data get transparency into the low voltage network. After putting it into the research context, I will show the use cases and those that we actually tackled. I show the system architecture that we used, talk on the validation and the results, and then come to some prognosis, which we do, and pseudonymization, a specific topic that needs to be treated, I think, and afterwards the summary. So the perspective, there was a phase one in which in FURIES there were the iGrid Sense and Grid Box developed, which in the phase two were to be used in the Arbon Energy Demonstrator for the direct measurement to get transparency. And then there was this second approach of a demonstrator, our demonstrator, which said, just use the smart meter and use digitalization and then try to come up with similar results. And this project is done in conjunction with FHNW, Windisch, then University of Lugano with Arbon Energy, and DSO, and Siemens, Switzerland. And the advantage of Arbon is that they are already for several years 100% smart. So they have around 10,000 smart meters for every household. And actually around that town, there are others that are also connected to the system. So what can you do? In green, you see directly which parts of such use cases were tackled in our project. Visualization, the load of transformers and other objects in the network, the reactive power losses. Then you can look at what will happen with the network if PV or e-car charging is increasing. You can try to optimize the topology, and a special topic is validation of the data which you already have, because there's a second source of checking. And then you can do the business case on PV production. Actually, there's a project in parallel that we did, which I will not touch on, and that led to a battery investment of in Arbon for 1.3 megawatt hour battery, which was ordered and put into operation during our project. And then I will come a bit to the direct measurement of voltage by those smart meters used in Arbon. Here is in gray what I will actually talk about now. And an outlook, using such data in new cluster algorithms will be touched upon in a new project starting in this year. Now the system description. We have a data bank which we created, which has a static and a dynamic part. The static gets the GIS data, so the cables, the smart meters, the transformers with their positions, their electrical data. They are stored in this database, and then you have the prosumer data, the smart meter data, be it with PV or without. It's 15-minute values, and partially we have them with 1 second values if you use the PSS measurement technique. And on top of that, you also have power quality data, which we stored in the database. Now from this static data, we go into a topology builder, and using the dynamic data, we can do a load flow calculation, which in the end we store in the database. And what it actually then shows is when you put up the sum on the cables, it shows the losses or the load in percent of the design value. And if you look at the nodes, it will tell you the voltage at a given spot. Now, the digitalization project is typically in the sequence that I show here, from connection of data through validation and analysis in a circle loop until you believe in your data, and then you do a prognosis. And I think the network optimization and decisions, that is not treated by our development project here. So something which maybe not as research driven as most of you would like to. It is very practical, and maybe it was the most important to get our project running, and that's why I show it here. When you want to do some serious forecasting, you need to validate both your GIS and the smart meter data. You have to put the smart meters to the right positions, and you have to connect the cables in the right way. And in the beginning, there were data that were a bit fuzzy. It was clear they are false, and then it wasn't clear why that would be so. The Arbon said, well, my data are fine. You can look at my GIS data. Everything's fine. And then with the graphics I show here, we could solve that, because there's first on such an open source map, the GIS data put in my circles. Let me get this here. Here in these circles, you see just the GIS put, and then with black around it, you put the second data which is coming from the topology builder. Now, if you don't have this section covered with the topology builder, then it's obvious that somewhere here, or maybe here, there is a connection in XYZ which is mismatching. So you can give a direct hint to the one who is supposed to do the GIS database where his problem is. And with this graphic support, it is very fast, and that actually helped enormously to get the database debugged, which was for the purpose that it was used in the past. Perfect, but for the use of this topology building, it wasn't sufficient, because sometimes there weren't connections between the cables. So this graphic was done immediately.
You must have muted.
Between looking at data from a smart meter which get bills, so from the SAP system, so to say, where the...
Sorry, we lost your presentation. Just
when was that?
now, 10 seconds ago.
On this slide or the other slide?
I do not see any slide at all, so I cannot say.
Okay.
Sorry for that.
So how do I
You must have either...
Okay, is it coming back again?
Back again, thank you, yes, fine.
Okay, so then I have to... was this still shown?
This is correct, we saw this, okay.
Okay, so then the next topology check is when you compare from different data sources. The first data source is you get the list of all consumers who get a bill. And the other one is you get a list of all the smart meters that are in the GIS. And if you now get the list of those who you see in one database but not the other, and vice versa, you give these points the brown ones here or the more red ones. You can select them just by clicking in, and then you get immediately access to which position in the GIS database you have to improve to actually get 100% of your data. And now this is not debugging, that is just useful if you want to know where the PV is in Arbon, then you can just click on the generators and you see that. So this graphics helped us to get the first debugging. The next one is you need to substitute and eliminate data. So substitution is if the smart meter data didn't come during the night, then you just put it in. In this case, for the load, we take the value of the week before. In case a PV meter is not there, you put the average of the production during that day coming from other PVs and multiply it with the peak power of the missing PV, and then you inject it. And then there's another situation in multifamily houses where there's several smart meters and all different scenarios pop up. So you have to take carefully out those smart meters, which would put, for example, like here, PV 3 times into the game. So you make sure you have it only once. In this case, we would use just this blue one and not this one and this one. And so you take all the consumers plus here this one, and that would be the correct number of smart meters. And with all those corrections, we come to results that I show now. This is if you take 10,000 smart meters and compare this to the high voltage transformer power measured there at one spot. And if you take one minus the other, then what comes out is here the middle plot is the losses that you see. So here it's 3 months of data, and you see typical load, typical losses around 4%, with a little bit higher when the load is lower, like in the vacation time of summer. So the no load losses make up for a higher percentage of losses, which is obvious. And then after those corrections, which you actually see here, so those two cases you say here in percent how much they contribute. If you do all those corrections, still you see some cases here, like a Saturday, Sunday event of 100 kilowatt, which happens every now and then. So we didn't look at this one. That would be such a typical case where it could be interesting for the DSO to better understand what's actually going on there. And typical cases, I mean, I just show it on this plot once, but during the project, we had several cases where we showed such funny events. And that was then something that interested the CEO of Arbon, because that was something where in his system, there was something that maybe he discussed earlier, but forgot about it. And that was something that made this type of data analysis interesting to him. Same analysis for a transformer station below, and there we have more corrections because at the end of a line where houses sometimes come get the power delivery from another transformer station weren't correctly built in the GIS system, so higher corrections need to be there. You don't see that on the total of Arbon because you just take the smart meter and you don't care if the switch was to the right side or to the left side. So the systematic error is a little bit higher, but the mean is about the same of losses. So it's no big difference of the statement what you can do. Now, when it comes to visualization, here we have a simulation run using all the smart meter data of a day, and we actually store them in 15-minute values, calculate voltages and the currents, and here is the color coded thing which says voltage red is in the center of the dots, so where the transformer is highest, and during the night the longer the line the lower the voltage. That is not unexpected, and the load on the line is very low. When it becomes interesting is when you get to the day, because at the end of the line here there are several houses with PV, and actually then voltage goes up compared to the transformer station, and that is when it was interesting. Now, in general, is that possible to calculate voltage by just summing up all the loads measured by the smart meter and calculate it from the inductances of all the cables? And what we show here is that it does make sense because we have a direct measurement on the smart meters, and we compare those here, the load for calculation in the time plot here, brown against blue, this power snapshot, and you see it follows nicely. And here is a scatter plot against measured against the calculated, and again here that follows fairly nicely. In fact, we have, because this calculation takes the mean of 15 minutes, we compare here the mean which we can trigger against a min or max during this 15 minutes during the trigger time. And actually the min max of course is a bit higher, and the black one follows nicer to the mean value calculated from load data. So what we think is that GIS data and smart meter data that are debugged, so they are validated and are properly taken, and then doing the calculation will give you reasonable voltages. I say here systematic error is maybe 25%, and statistical error just by the digitalization of the smart meters around 0.3 volts. So what is the next one? Prognosis. We want to know what the voltage is where the PV is supposed to be installed in the household. So today's voltage calculated is during the evening, highest loss, and then you calculate together with PV, and you see during the day, that's not unexpected, when PV production is high, you get some voltage increase. And now what is interesting is if you want to compare that to your situation of today, you take the year data at that transformer station of all the time slots, all the data in 15 minutes packages over the full year. The red one is what you had before, and the black one that pops up now to positive voltage increase is what you get on top if you put PV. So that gives you a statistical information on what will happen. And now last, we get to the pseudonymization. We know that this data from consumers, they are sort of touchy. And so we implemented a software thing called role-based access, and the roles and the access rules we defined here with the crosses. So some people may use only GIS data and look at it. Some others may just check the smart meter data, but not where they are. And some may do everything. And then the researchers, for example, they may not look at who actually has the loss, but maybe just get some data. And in the end of the day, what we do then is we change the topology as well. If that would be a transformer station with the cabling to every household, so one stands for one smart meter at a household, then we shall not be able to look at every single smart meter value if we don't have the right to. So what do? Here in this case, we say at least 10 smart meter need to be put together. So here, for example, the yellow situation, all these smart meters, you sum them up, put them here at that position. You say this is 10 smart meters, and you add those 10 smart meter values every 15 minutes. So the cabling would just be from here to there, and all that you would not see anymore. But like this, you would have the pseudonymization where you see all the data to the transformer station when it comes to loads, but you do not see all the loads at the single household. So what's the summary? Smart meter data really give you a new transparency of the low voltage network if you have 100% smart meter rollout, which we in this case had. And with our new strategy in Switzerland, we should have that in a lot of DSOs within the next years. Now, the proposal for staged rollout over several years should be that you roll out transformer station by transformer station up to 100%, because if you have a PLC system, at least your communication gets heavily improved. The data validation is much more efficient, and the profitable use of data is from the moment that you debugged or you validated your data. And if once you validated the data, it is possible to calculate the voltage all over the low voltage network. And as I showed, you could then as well check what will happen if I add more PV at a given position or if I put heavy loads. And then the local voltage calculation may be used instead of a direct measurement to save cost. So in the end of the day, the statement is digitalization may eliminate hardware costs of a low voltage network and measurement equipment. It is a software solution against a hardware solution if you do work on the data, if you do your digitalization project properly. And now I look forward to questions if there are any after the full day.